Alright guys, we're on lesson 9.3, task 2, create exponential and logarithmic functions. Alright, it says to create an exponential model using technology. Alright, so I'm not going to go through this because this is exactly what we just done in the last task. So in task 1, I put these values in just like this and showed you how to create an exponential model. So here they're doing the exact same thing. So they created an exponential model, and you could see in the calculator the equation in red is the equation that the calculator made. So in the last task they did it by hand, and this is the blue line. Okay, so it says what is the exponential model of best fit? Alright, the exponential model of best fit comes from the calculator. So A is 322.08. Okay, so probably the first one. And then your B is 1.11658, which is close to 1.12. So this is the equation or the line of best fit. Alright. How does the model compare to the one created in task 1? As you can see, both of these are good models, but the one in red, the one the calculator made, goes a little bit more in between the points. So your calculator's model is going to be a little bit better than the one created on your own. And again, this is a minor standard, so we didn't go through the doing it by hand. If you want to do that, there is information in the book, but as long as you know how to do this on the calculator, you're going to be fine. Alright, so it says, how does the model compare to the one in task 1? Again, it's a little bit better because the calculator just does a little bit better job of getting it exact. Alright, so it says, in this model, if the model continues to represent the relationship, how many newly built housing units would you expect to be sold in 2022? Alright, so remember in task 1 it said let 2011 be year 1 or year 0. So in our calculator, 0 represents 2011. So that means 2022 is 11 years after that. So if we use our model, let's find our equation up here. Alright, so if we use this model right here, so we can say 322.08 times 1.12 raised, well, let's see, I need another parentheses here. Alright, now 1.12 raised to the x power, but we're looking for a specific year. We're looking for 2022, which is 11 years after 2011. So if we hit enter, that gives us 1,120. And if you remember, it said in thousands of years. So 1,120 in thousands of years. That means you would add the 3 zeros back. And that's how you use the model to find a specific date. So knowing that this is 11 years after, all we had to do was plug the 11 in for our x. All right, that's all for task 2. If you have any questions, please let me know. All right, guys, lesson 9.3, task 3. All right, it says to create a logarithmic model. You can create a logarithmic model for a real-world data if an exponential model already is known, or by performing a logarithmic regression. All right, so we're going to do that again using the calculator. And it says P equals 81 times 1.09 to the t power. Models the wolf population. So this is an exponential model. And remember, a logarithmic model is the inverse of an exponential model. So we're going to skip through. We're going to skip through some of this. All I want you to know is that you can use your calculator to graph both exponential and logarithmic functions. All right, so this is the ordered pairs from your exponential model above, the equation that we've seen at the very top. And what they want you to do is create a logarithmic model. So remember, to find the inverse, you switch your x and y's. So in this table where we have our t, our time from 0 to 12 years, and then we have the wolf population here, to find a logarithmic model, we have to switch those. So we put our domain is now our range, and the range becomes the domain. So if we enter this in our calculator just this way, and I've went ahead and entered this data in here, you can do the same thing as we did before. Once you go to Stat and you hit Edit and you enter that list in there, then you hit Stat again, and now you're going to calculate, and this time we want a logarithmic regression. So we're going to come down here, and remember LIN, that's linear, and you can do a quadratic, a cubic, a quartic, and exponential, and now we're going to do a logarithmic regression. So ln, remember that's your natural log, and it's going to pull from our list just like it did before, and it's going to create this equation. So remember, logarithmic function is the inverse of exponential. All right, just like before, we can go to y equals. If we go to vars, number 5 statistics, and go over to equation, we can copy that regression equation into the y equals, so that way we can hit graph. Now, I've already changed my window. You can see here that on the window that this starts at 82. Okay, so my x's go from 82 to 239. So they've just expanded the window up through 250. So I went ahead and changed my x's from -1 to 250. And then you can see on the y's goes from 0 to 12. So I just went from 0 or -1 to 13. So when I hit graph, that's going to make my function look like this just because I changed my window. Okay, so again, you can go to Stat, Calculate, and you can do a exponential or logarithmic regression if you have your table of values in there. And a logarithmic regression is always going to be the inverse of exponential, which means if you have a table of values, you simply have to switch the x and y. All right, here it just says, why do you use the population? That's because you're switching your domain and range. All right, wants to know when you can find a certain population. So you can do that using your table of values. So if I go to after how many years would you expect the wolf population to reach? All right, so you're going to have to go, I'm not going to be able to find it on my calculator since I've got the logarithmic regression in there. But you're going to go to the equation given in the beginning, and then you're going to put in 300. All right, put in 300 and then solve to find out how many years that would be. So how many years does it take to get 300? All right. And then do you think a logarithmic model is a good fit for the data? I would say yes, it follows close to many other points, and yes, it has points on both sides. So let me see. Let's just kind of guess here and see if this goes up. This is at 239 at 12 years. I would say probably, I would say close to 15 years. Let's just take a guess. And 15 years is a reasonable guess. So again, to find the exact number here, you just have to take the 300 and plug it in for P and then solve for T. All right, so that's how you can use your graphing calculator to create a model for an exponential or logarithmic function. If you have any questions, please let me know.